Okay, I got a lucky break here. Well, it's not really lucky. You know, you can't look at these diagrams too long. Really do need to study. That's the wrong one completely. This diagram has some real interesting hints on it, which I didn't pay much attention to. Shame on me. But it's going to help me identify this capacitor, because it shows it. It shows it right there. C1 right there. C1, I go on the schematic, look for C1, and C1 shows up. Where did it show up? C1, 0.1, right there. Okay, so it's 0.1. So I'm going to change that before we go any further, now that I know what it is. Take a 0.1 here, and it goes to ground. So I think I can just install it like that. Okay, all the power's off to the radio. That guy there. The wire broke. Okay, he's out. Careful. One of the lessons I've learned is don't do anything when you got a soldering iron in your hand other than solder things. If you got the soldering iron in your hand, and you start doing other stuff, guess what's going to happen? You're going to end up burned for sure. Oh, it's just not quite long enough. Well, here's another ground point right here. Right there. Excellent. We'll go there. And with this capacitor changed, then there's no more risky capacitors. All the original resistors are still in there. And they are old, so I really do need to test them up. It's not very good at all. Let's get this a little better. You know, all the excitement we feel today as the internet expands around us and provides us all these wonderful opportunities we never had before. Must have been the very same thing going on at this point in time too, when this radio was being built, was being sold, late 30s. I think in the 30s, both the United States, Canada, and probably many other parts of the world were busy spreading the newfangled electricity around. And you know, lots of people had in the cities and stuff like that. People had electricity long before this, but in the more remote areas, electricity was not being distributed. Don't know about this year. I don't know the history that well, but I would imagine in 1938 there were still people getting electricity for the first time in their homes and their farms, most importantly. some areas, very common in the States, solve the problem of private enterprise would not electrify the countryside, the farming and that. Just wouldn't do it. Not enough money there to be made. You know, the load is spread out, it's so thin, you need a huge electric system to reach everybody. So to solve that, in the States, co-ops were set up. And then those co-ops could borrow the funds they needed to go ahead and do their development. Canada was a little different. Canada went for just public enterprise. And the hydro systems were under public ownership. Co-ops are a form of private ownership, membership ownership type thing. So quite different systems in the States from Canada. And almost every other country has struggled with the same problem of getting electricity distributed in the country areas. That was a long time ago now, of course. To hear me talk about it now, if you haven't ever thought about it, you kind of wonder, well, what would the problem be? And, okay, so there we are. We have now replaced that last capacitor. Very good. And I've lost track of what it is I'm trying to do here at this point. Oh yeah, we're getting ready to do an alignment. Still getting ready to do an alignment. Okay, so I think I got things all set up here now. I've got the signal generator. Here's the, let me tip my camera down a little bit further here. Okay, so this is the signal generator output passing through a capacitor, going into the grid of tube here. So that's where we inject the signal. And everything else is connected as it was. So we should be able to just fire this radio back up here. Everything looks okay. Hold on. We got, yeah, this meter's not connected anymore. See, I'm suffering from flip lead shortage again. Okay, I think I got a solution here. Oh my, oh my, oh my. A new error. I made a new error. I thought I was recording on the video when I was not. And when I went to stop it, it just started. So, uh-oh. Not sure what I was not recording there. Anyway, it's definitely recording now. So as you can hear the tone there. So that's set at the IF frequency. .455. And what I want to do is I need to hook up a voltmeter on the output here so we can monitor the output signal. And I got to figure that out because I'm out of clip leads. So, give me a moment here. Oh, I don't know what to say now. I made another little boo-boo here. Because I'm making assumptions, I connected up my output meter to the two speaker wires. And I then caused a resistor to cook right there. Nice little smoke came up. So like a dummy, I've gone and applied a ground where I shouldn't have. And I'll bet you that's a 2.2 megohm resistor. Ooh, it's going to be a little hard to tell for sure. Let's see. I connected my leads. That makes sense. You know, this is frozen here. This is exactly what I imagined to be going on with the speaker. We have an output transformer. The secondary is driving the speaker, and there's nothing more about it. There's no grounds, there's no nothing. So I casually applied my voltmeter leads, as I've done many times in the past, to the speaker leads. These leads coming out here. And shortly after that, a resistor smoked. Why would that ever be? Because there's some kind of ground sneaking around here or something like that going on. Something more to it here. Now I've gone and fried a resistor. Now I'm going to shut off the power to the radio completely, because I certainly fried that resistor up. I got to replace it now, and we might as well check the rest of them while we're at it. I guess that's where we're at here. Backing the bus up. So, just making sure nothing is on still. No, there's no power to the radio whatsoever. Well, what did I do here that was dumb? Now, let's just get the voltmeter out here, because I really didn't expect there to be any concern with connecting the meter to the speaker leads. I think I'm on the verge of learning another lesson here. So let's see what's grounded around here. Look at that. Well, that answers that question. Well, you can see the ground. What have I done here? Done. No, this is not burning up the way I thought it was. This is something else happening. Ooh, phooey. What else would be happening here? Help me, I've lost control of the situation completely. The output on my... No, it never went high. I always had this on. The B plus never went high. This is where the B plus ground point is made. So, wow, this doesn't make a lot of sense at all to me. At all. Why would that happen? Let's just do a voltmeter. Well, I'm going to turn off the video and ponder this, because it's going to get really quiet in my shop for a while while I try to come to grips with why did that resistor decide to burn up. Hopefully I'll have the answer in a moment. Okay, so the first thing I'm suspicious of is that the output transformer has a short circuit in it, or something like that. Where is the output transformer? Oh, the output transformer. Oh. Stop the presses. Stop the presses. I'm doing something dumb here. Dumb. Oh man. Very dumb. I've actually left the output transformer back on the speaker in the radio. And oh my god, I hooked up my speaker directly to the... Yikes. Okay, dumb move. Dun, 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 dun. Okay, let's bring in the right speaker. I'm an idiot. Jimmy is an idiot. Okay. You know what? If I did all this right, there would be no fun in it. Okay, so we'll bring in the speaker with the output transformer. Oh my god, I'm such a dummy. Dennis Carter, come stand in my shop with me while I do this. Well, I got to change this resistor because, excuse me, it got fried quite thoroughly. And that's supposed to be a 680, I believe. 820 ohm resistor here. $820 ohms. Let's see what it's good for. What are you good for? Maybe it still shows 820. I've always been quite surprised by the survivability of some of these parts at times. So let's just see for fun. We'll put this on. 2000 ohm scale. 860. It's not that far off, is it? But it's probably quite unreliable. I mean, can you see the crack in it? There's actually a crack right open. Let's take a closer look. So if you see one of these, something like that, there's the crack. Yeah, but amazingly enough, it's not that far off. 860. Okay, let me hunt down a capacitor or a resistor. Okay, so I don't have an 820, but I can do 800 if I just put these two resistors in series here. Let's double check that. Make sure we're getting close to 800. 780. 820. You know, that's good enough. That will be good enough. So, you know, if you like my videos, it may be because I seem to make one mistake after another. What's going on here? And as I may have said before, if you want to understand how something works, the first thing you should do is mess it up. Disturb the system. And then you find out a lot of stuff about it. So, see, I'm right to make mistakes. And there it is. Ready to go in there. I hope I didn't do any other... No, I didn't do any damage to the radio. The only thing that took the heat was that resistor. Yeah. Because inside I was quite nervous that I'd somehow stuck inappropriate voltage on the filaments. That's what I'm so worried about in this radio. The tubes are really sensitive. If you whack them with extra voltage, I don't think they're going to stand up to it very well. Okay, it's not coming out of there. Okay. Yeah, one of the things that makes this work fun, I find anyway, is the unpredictability of it. You never know what you're going to meet up with. And part of that I think that's soldered. Let's give a tug on it. No, it's not. Okay, my little radio. Soon you will feel comfortable, because I will once again have you hooked up to your output transformer. And, kind of wonder what that did to my speaker. Sticking it where the output transformer should be. That certainly explains the low output. Once we put the, it should have dawned on me right then and there when the output was low, that things were not right. Now, let's hook up the proper speaker the proper way. It's these two guys here. You ever wonder what happens if you just cut out the output transformer, hook your speaker straight up to the plate circuit of the tube? You've seen it. Doesn't work well. It's a horrendous impedance matching. You got the impedance of the tube's going to be, I don't know, 1500 ohms or something like that. The speaker's 8 ohms, so you're trying to use a 1500 ohm internal resistance supply to feed 8. You're going to throw away 95% of the power inside the tube. Very little is ever going to make it to the speaker, and voila, that's why the speaker was quiet. But of course, when you're testing a radio and the speaker's quiet, you tend to think of other things. At least I do. Other causes for that. Now I got to get my meter hooked up here somehow, and I'm once again in a drastic shortage of leads. Since I had thought of something clever, which turned out not to be clever. Oh, I have to break down and make some more leads. No, I see an alternative. I'll get this hooked up in a couple minutes here.